Welcome back to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson from Proteum Machining, and this week I'm joined by Brian Dinola of Autodesk. So, welcome, Brian, and thanks for joining me.
Yeah, hey, thanks for having me, Dylan. Appreciate it.
Yeah, definitely. So, we kind of virtually met through Jake Yates, and you have done, work with him both at his day job and at his shop. And we talked a little bit last week, just as kind of a preamble before the episode, and it's your story sounds really, really interesting and kind of a cool way to come into manufacturing and software. So I definitely am looking forward to having you on and getting to share your story with my audience.
Great. Yeah, Jake and Ryan over there, they're the comical pair. So definitely a good time working with those guys.
Awesome. Well, yeah, let's jump into it then. How did you get into software? How did you, because you started also in the Delcam side before they got acquired by Autodesk. So, what was your first introduction to manufacturing, I guess?
Yeah, so after college, I started working for my family business. My parents own a jewelry store that they started about 40 years ago in my family garage. And I didn't know what I wanted to do after school, so I started working at my dad's retail store where they did a lot of custom manufacturing and design, mostly of bridal jewelry, so making somebody's engagement ring or wedding band or anniversary gift, and doing a lot of repair work for both wholesale, so other businesses, and also retail. And I was doing things like sizing people's rings and fixing their broken chains and bracelets and putting stones back in things. Started to get into doing some of the custom work, and everything that my father did was sort of old school, right? It was hand filed, hand pierced, every hand carved wax, and then lost wax casting process. Everything was sort of manual. And we went to a manufacturing trade show at the Javits in New York, and I saw this software there that was doing 3D modeling of jewelry. And they also had these little desktop CNC machines along with some 3D printers. So I saw this and I was like, this is the way to do this. Like getting a block of wax and carving it by hand to me was crazy, right? I was like, if you could do it in the computer and you wanted to make something and then make a mirror image of it, like a pair of earrings or something like that, or even just making things symmetrical. I mean, doing things by hand and doing it very accurately and precisely and being able to mimic things and make them symmetrical is really challenging. Whereas in software, this sort of comes for free. Um, Obviously, you have to learn how to use the computer and the software, which is often the big challenge with all CAD CAM software, right? None of it's easy. Um, but yeah, we acquired some software that was actually based on a surface modeling package. This product called uh, Matrix, which was based on Rhinoceros, which is a NURBS modeler. And I started to learn to do surface modeling. Just took their training and stayed up till all hours of the night learning to do this, and started to do 3D printing from service bureaus. Right, so we had some other contacts that were printing with solid-state machines, which are a thermoplastic printer, um, and also Vipers, which are 3D systems, SLA machines. Right, so these are laser-based photopolymer machines, um, and then got into a few other machines and ultimately wanted to bring some of this in house and got a little desktop milling machine that was a Sureline. And this is like, you know, hobbyist level equipment, right? I mean, Surelines are fairly inexpensive. The screws on these things are just like your typical 60-degree V thread. Not exactly the most robust scenario, but hey, if you're making little train parts or something, I'm sure it's okay. And I bought a flash cut CNC stepper motor controller and hooked all that up and retrofitted this thing and used a CAM software called Desk Proto, which was a software that can import an STL machine apart and do it pretty easily without a lot of knowledge. And I was machining wax and all this kind of effort around learning to do CAD and learning to do the CNC machining was, internet searching, which was helpful, talking with some friends in the industry who had experience in this area, and then just staying up all hours of the night, just figuring it out, right? Figuring out all the wrong ways to do it first. So once I made my way through getting into some of the CNC, I found out why you shouldn't try and do CNC so inexpensively, and later moved on to some better desktop machines. These mini tech CNC machines, which they had THK linear guide rails and ball screws, uh, NSK 25,000 RPM spindle. And was able to get a whole lot more repeatability out of these things without having to fidget with the machine and adjust gibs and backlash and all these other fun things that you get out of lower cost technology. And also got introduced to a controller that I know is really big with hobbyists and retrofits, Mach 3. I'm not sure if you're familiar with that at all. Um,
Yeah, yeah, I'm definitely am. I don't think you can escape it in the machining trade in one way or the other.
yeah, so I wanted to implement that because I was having some challenges with this flash cut software that just didn't suit me. And I don't want to do some more customization to it. And the fella who owned Minitech, this guy, Jack Held, who's a good friend of mine at this stage, had set me up with a controller that he was struggling to get to work. And it was another sort of, stay up late night for weeks on end adventure in integrating a tool touch off probe and writing some little macros to automate some of the processes and customizing the user interface of Mach to do what I wanted to do, kind of make it a CNC for dummies, right? Because I had no formal machine training, right? This was all, I just wanted it to work how I wanted it to work. Um, and in doing a lot of that work, learned a lot of the sort of proper ways that things are intended to work, and made things a little bit more streamlined in terms of the process and workflow of the controller, and send it back to him in order for him to use that as his sort of platform to sell with his machines. So we sort of both got something out of it at the end of the day because I got some more equipment from him in trade, and um, went through the learning experience, and he got to have a more robust product offering. And we've maintained a relationship for some time. I actually did quite a bit of work for Minitech doing application engineering. So as I was working with my family and doing sales and manufacturing in the retail business, it got a little stale after a little while to just make jewelry. I wanted to learn to make other things. I really enjoyed the whole software and computerized component of manufacturing. Right, if I could figure out how to make software and computer controlled motors do something, I liked that approach. Right, it was fun.
So,
Uh,
how did you learn to code? Was this all the same kind of thing, late nights and just
yeah,
learning it on your own, or?
Yeah, I don't know what I would do if it wasn't for, doing web searches and being, in my 20s and having nothing else better to do besides drink beer and stay up late at night and see what I could figure out on my own. I, I learned more after college, right? School was more in session for me after I graduated than before. Um, so I actually went back and took some classes because when you start to learn to do coding and things like this, you realize that all that boring math that you took in school, whenever you would ask like, well, what am I ever going to use this for? And never really got a good response. Later on, I learned like, yeah, actually, a good part of being a good coder is actually having some decent math skills. Um, I went back and took some basic science courses in school, but this time paid attention and took calculus and physics and a couple other little things where man, it was more helpful when you wanted to start to do more intricate programming, and started to learn a couple different languages, and just try to implementing it in things. And having a small family business gave a lot of opportunity to do so. So making little programs to like track part-timers hours rather than my parents keeping it in like a handwritten journal. um, Implementing a whole POS system that I had worked on with a friend of my father's from the firehouse, where we set up PHP and MySQL, JavaScript, and made this whole browser based POS system that ran the jewelry business to take in work, whether it was repair, custom work, to create invoices, manage all the inventory, and really it was the piece of software that ran our business. Also did some did some website work, front end and back end work, to develop our little website at one point. We had inventory up on there when I was there to maintain it. It's a little different story now without me being there to do all that kind of stuff. But yeah, lot of late nights and a lot of just figuring out how to do things. And probably if I had known and been trained, I could have learned something in an hour, but instead, spent 8 hours. But really understood it after spending a lot of time on it and working with it. And some of the learning was actually teaching others. So I was doing some CAD training for others. I even taught at this little trade school down in Virginia Beach that since moved um, to Tennessee, but the new approach school for jewelers. I went down there and took some bench courses, and was giving the owner a hard time that he was living in the 19th century with having everybody do everything by hand and not having any computer classes on CAD. And that was really the next thing in jewelry, because jewelry industry was kind of late to adopt CNC. But when I had worked with him, he was like, "Look, if you think we need it so bad, I'll pay you to come down here and teach it." So I did. So 1 week a year, I would go down there and teach this class, and you really know what you're doing when you can clearly teach it to someone else, right? So you have to truly understand it. Whereas, you watch somebody do something, then you try and do it, and until you have to explain it to somebody else, you don't realize how much you do or don't know, and things that you sort of fumble through. And when you can really break it down into its core components and explain it to somebody else in a clear manner, it forces you to really understand the process. I had done some videos on doing CAD work also, which furthered along in that process, and it really just makes you sit down and think about what are the steps and what are the fundamental concepts in the process. And the biggest thing that's good and bad about CAD CAM is it's hard, right? I always think about software and using software as, could my mom use it? Right? Is this easy enough that if I gave it to my mom, could she use it? You think about your parents or somebody, and they struggle to program their phone and their VCR. And when it comes to CAD CAM, it's even more of a challenge. Like, hey, if I was like, hey, can you design this ring, or can you do this? Would it be possible? And if you can make it where my mom could do it, then your software's got to be pretty good and easy to use. Um, you know, I will say, in working with my father, even in his older age, he was able to pick it up. He continues doing all the CAD work and CNC work on his own, because they still have the business, and they still do all this custom work. But I decided that I didn't want to own a jewelry store, and wanted to really get sort of the next step. So it's like, okay, well, what do I do after I'm buying all this stuff? Well, I'd rather work for one of the companies that's selling it, and go work with their customers. So After doing quite a bit of work with Minitech, I had access to all sorts of software, right? I used other CAM systems. I used one, Visual Mill, quite a bit, which later became an integrated system called RhinoCam. I had MasterCam, and then back then there was, and maybe still today. I'm not involved with it so much today, but Napster and torrent sites and all this stuff were big, right? From when I was in college till quite a few years after that, and you could get your hands on pretty much every piece of software on the planet. So I was able to get exposure to all different types of products and what they do. One that I was familiar with that was used in the industry was a Delcam product called ArtCam. And when I was looking around for places to work, I was like, okay, hey, yeah, I know Delcam from their Power Mill software and especially their ArtCam software. There's a Delcam office, less than a half an hour from where I live. And I had looked around and saw what jobs they had, and they were hiring. So I applied there, and when I go there, you know, they were Delcam, but they weren't Delcam, right? This was actually the acquisition that Delcam had made back in '06 of a company called IMCS, which was the company that developed PartMaker. And it was primarily run by the Fishmans, so Lena and Hanan, mother and son. She was a computer scientist that came out of a lot of background with working with Bridgeport, and developed what later became EasyCam and ultimately became FeatureCam much later on. Uh, so those two products, interestingly enough, started way back in the day from sort of the same uh, core source at the end of the day. But she started this company, and they had this little product called Part Maker. And sometime in the late '90s, they sort of stumbled on Swiss, and what they had done was started with turn mill, kind of went over like a lead balloon because back then the machines were not very robust in their milling capabilities, right? The live tooling on them just wasn't so great. So the software didn't go over too well, but they did find some inquiries of people who wanted to program these Swiss machines, which they had no clue what they were. Uh, they had hired a few guys from Synthes, and Synthes is a medical device manufacturer, which is now owned by DePuy J&J. And these guys ran Swiss machines because Swiss is quite popular in a lot of medical device um, manufacturing, implants, instrumentation. So these guys picked one particular fella, Greg Osborne, who's actually still with Autodesk, coworker of mine, that is the leader of the post processor team. Kind of taught the group what some of the domain knowledge was about programming Swiss. So they had this product, and kind of started finding more and more people, and Swiss is kind of the black art of the machining industry. Um, but they got this kind of niche, right? So I show up for an interview at this place that had a decent user base and also reputation for programming multi-axis and Swiss lathes. So any sort of multi-channel machine where you're running more than one G code stream simultaneously. And I didn't know what a Swiss machine was, right? Everything I was doing at that time was 4-axis and 3-axis desktop milling. I'd done some mold making and some other products to make like little prototypes for medical parts and dental parts and things like this. But my introduction to machining was not to sort of understand all the machines, right? So I show up thinking I'm going to see ArtCam and Power Mill at this place that I'm applying for a job at, and lo and behold, they show me Part Maker. And it was funny because part of the interview process was you had to take the software, take it home, learn it, and then come back and do a demonstration. So I took it home, and when I first saw Part Maker, I was like, man, this stuff looks like it was developed in 1985, right? Because I was used to seeing so much software. I'm like, who uses this? And when I went back, I was asking like a couple of the other guys there, not Hanan, who was later my boss that was interviewing me, but because he would have taken insult to it. But some of the other guys like, does anybody use this? I've heard of these other products, but who uses Part Maker, right? And part of it was because I was in this world of people that were programming Swiss lathes, and the process is very different. And you know, later on, it was came to light that the simplicity of the software is what really made that software so great. But yeah, when I first looked at it, I was like, I don't know if I want to work here. This technology looks like it's ancient. And it took me a while to sort of appreciate it for what it was and how good it was at doing what it was. And then spending a lot of time with customers to help them program their machines, right? So I was learning what Swiss was. I came in as an application engineer, and I was doing training and tech support and helping people with turnkey projects and things of that nature, working with machine builders, and um, spent about a year in applications, just kind of soaking up as much information as I could. And obviously, I had some coworkers with a lot of domain knowledge, so I could just ask them a million questions, driving them crazy, trying to understand everything I could about this.
Yeah,
Um,
that must have been quite the learning curve going from, never having run a Swiss to having to be the application engineer telling people how to program it.
yeah, the when it comes to software, and I find this with all the software companies that you think like, oh yeah, the guys who know the software, they must know all this stuff. And the reality is you just have to be one page ahead of your customer in the manual, and you're okay.
Yeah.
So you'd be surprised what you could get away with. Now, obviously, there's more complex projects where really having the experience matters. But a lot of things when you're training people and doing general tech support, the knowledge level doesn't have to be there. It's really the aptitude that matters, and the knowledge and experience just comes with time. But yeah, spent a lot of time working with a lot of customers, and you know, the amount of learning that I was able to do traveling all over, training customers, working with customers, was huge. I moved into sales after about a year, and most of what you find with salespeople in manufacturing is they know how to sell you something, but they don't know much about what it is that they're selling you. And I had some sales experience from working in the family business selling jewelry, right, engagement rings and things of that nature, but not really software. So I kind of worked with a couple of the other sales guys, and I was their applications slash sales helper, right? So I would go on sales call and do the technical demonstration, and they would sort of be the salesperson, and I was in training for sales. And that really taught me a lot about helping people understand the value of what it is they're purchasing, and not always having to dig down into the weeds, right? When it comes to people purchasing software, they want to know that it has certain features and functions, and maybe does something that their previous software did, that they had, but they don't necessarily need to go into every little detail. And sometimes, focusing on solving the problem is the most important thing, and not figuring out which button and widget that you have is so cool. Um, but yeah, after doing that for a while, we started handling some of the other Delcam products. So they hired a guy, this guy Dan Vandy Wosteen, who also still works with me at Autodesk, and he came in as the power mill guy because Delcam wanted our office to sell more power mill. So he started with it, and I started learning it, and we started taking on more complex 3D and 5-axis work, right? Because part maker, like all cam systems, it did everything: turn mill, Swiss, wire, right? But the reason people bought it, 90 to 95% of the customers bought it because it programmed their turn mill or Swiss machines. That's really what we were good at. Good posts, good product for that. And that was really its forte. Power Mill, on the other hand, was great at doing all the complex 3D and 5-axis work. So I kind of got to go through a whole new learning experience with that product, delving into more 5-axis work and complex 3D, and that was actually more in my wheelhouse because making all these little miniature injection molds and waxes for lost wax casting and all that work I did previous with the surface modeling for jewelry design. That was right in the Power Mill wheelhouse, right? Because you've got all these complex molds and dies where you've got roughing, rest roughing, all types of 3D machining. So I really took to that quite quickly, and then it was really understanding all of the 5-axis terminology and technology and post processing. And that was a lot of fun to start to get to work with customers there and being able to implement that, and all these things that you do. It's all a learning experience for you as the applications or sales guy, and I was kind of playing both roles, right? I was doing a lot of applications for my other sales coworkers that were less technically inclined, right? I mean, one of the guys, I remember the first day he showed up, my buddy Jim, who actually is still with us at Autodesk in a different sales role now, sort of selling the mainstream products, right? The Inventor and Fusion PLM and Vault products. But he showed up day one and he goes, "What's a spindle?" And I'm like, "Oh, they hired you to sell CAD CAM? This is going to be interesting." Right. So, but he was a sales guy, right? I mean, like he truly knew to understand. Okay, do you have a need? How important is the need? How much money is it costing you? Is it worth spending X amount of dollars to solve that problem? Right. He really understood how to take people through the sales process and move on to the next one and manage a pipeline of people. But for him, the technology, it was sort of wizardry at first, but after a while and going to all these shops, everybody feels like they're unique in what they do, and a lot of people do a lot of unique cool things, and there's definitely a ton of talented people out there. But the reality is everybody has all the same problems, especially with CAM, right? Like, my post doesn't work, we can't figure out how to use the software, or the software just doesn't do this particular thing well, right? It doesn't program our Swiss or turn mill well. It doesn't program our 5-axis well, right? And this is the challenge with all these softwares is everybody says they do everything, but the reality is there's usually only one or two things that they do well, and the rest of the stuff is kind of there because they want to capture everybody's business, but they don't really have the same level of maturity, which is, I think, why you see such a fragmented market in the CAM industry. Um,
Yeah, that totally makes sense.
yeah,
I think that anybody listening can definitely empathize with that statement. That we all have CAM software and we know where it excels, and we definitely know where it falls flat on its face.
yeah, for sure. And sometimes you end up having multiples of them, right? And my favorite saying that I learned from my old boss is, right, the best CAD CAM is the one that you already know how to use. And like I had said previous, you know, learning CAD CAM is hard. No matter how easy somebody says that their system is, it's just got a learning curve to it. And sometimes it's a painful learning curve, especially in the shop where you have a lot of pressure on timeliness and delivery of product, where you feel like you never have time to learn except after hours between 11 p.m. and 3 a.m. when nobody can bother you.
Ain't that the truth? Oh my goodness. So then you were selling all of these, and then you guys got acquired by Autodesk
Yeah, so
at some point.
after about almost 6 years of working at Delcam, so it was 2010 where I started there. So um, 2016 we officially were integrated. We technically were acquired in 2014, but because of some legal reasons of acquiring a foreign company, because Delcam was based out of Birmingham, England, there was this sort of period where we operated as a wholly owned subsidiary. But we became, me and my coworkers, officially Autodesk employees in 2016, and that was interesting. It was like going from working in applications at part maker when I had first started there was kind of like being in high school. And then as the company grew and Delcam became more integrated, is it was more like college. And then, Autodesk came along and it was like, now you're in the pros. And it, while Delcam was a public company, it was much smaller and it wasn't driven as much by being on the stock market and in UK. Whereas Autodesk is a whole different game with as many VARs that it has and as many people as involved. I mean, when Delcam was acquired, they were doing about $75 million a year, something like that. I mean, we're a public company; you could probably go look up some history if it's still around on the internet somewhere. Um, and Autodesk acquired us for I want to say it was almost 300 million. And Autodesk now is working its way towards $3 billion, right? So it's this a huge jump in size of the organization. You got 10,000 people working here in all sorts of different capacities and products. There's so many products at Autodesk, you can't even keep track of them all. I think at one point somebody had said there was like 150 different products. I feel like I have a good understanding of them all now. If you ask me, I could probably tell you what most of them do and what they're good at and not good at. But I still remain in the specialized product area, right? So my role now is actually a sales manager, but I still spend a good amount of time in a sales individual contributor role. But the products that I handle are around simulation. And when I say simulation, don't think like CNC simulation. I'm talking more around the realm of FEA, right? So mold flow, which is a fluid analysis for determining if an injection molded part or injection mold is going to succeed, right? To determine things like material selection, optimization, making things more efficient, right? Just process planning where you can get a little bit of a crystal ball to find out, well, before we cut steel, is this idea going to work so well? So you can get things right on the first try and not on the fifth try. Um, and then obviously all of the cam software, right? So Power Mill and Part Maker, Feature Cam, also NetFab, which is an additive product that Autodesk acquired. There's some additive simulation in there to do um, laser powder bed simulation to mitigate build failures. Like recoder crashing and hotspots and things of that nature that happen with all these 3D metal printers. It seems like hey, it's going to be the easy button, but even those machines still have their challenges in setup and configuring. But CAM is still really at the heart of what I do, which is basically programming CNCs around complex multi-axis lathes and five-axis mills. Right, those are the kind of the things that really set us apart. And then obviously, as you know, Fusion's come along and it's been around for about 7 years. And the first go around, Autodesk pushed really hard to try and displace SolidWorks, right? And try to push it as a design tool. And we still do that today, but they later on found more success in CAM. And I think part of that is because of the pricing of the product compared to the functionality. CAM is a price sensitive market, and if you can provide a product at a subscription price that we do with the functionality that we do with Fusion, you get a big adoption. So there's been a lot of success around that. Now, there's a separate team that sells that, and quite a bit of the Fusion sales go through eStore. So it's a little bit more difficult to build a business model around a low cost, high volume product, right? Whereas historically, the CAM products from Delcam and a lot of these other acquisitions are low volume, high dollar products where it can be a longer sales cycle and having a salesperson and a technical person involved and doing demonstrations and going through all these things, you can easily build a business around that and be able to pay everybody that's involved, have resellers. Um, and now what's started to happen is Fusion's starting to accelerate where we're integrating some of this technology. So we've done what we've called unification. So things like Power Mill and Part Maker and Feature Cam and NetFab and some of the other products will come along as we've put them all under the Fusion brand name. So Fusion sort of becomes the entry to to the party, right? So it's your cover charge to get the base Fusion product, and then you've got some of these extensions that you've probably started to see, right? The manufacturing extension and the additive extension, which is actually technology from some of these other acquired products, Delcam products, the NetFab product, um, and some of these other ones like MoldFlow that are slated to bring some technology in later this year, where Autodesk has this pretty uh, unique business plan of making Fusion this cloud-based unified platform where you can kind of add on the different pieces that you want to do whatever it is that you need to do in the whole design through manufacturing process to try and solve a lot of the challenges that people have in manufacturing, right? Because if you have to go through the whole process and going from one software to another software, importing data, exporting data, going to different people. There's a lot of headaches in doing that. Um, even just deploying software is a headache, especially for larger companies that have a lot of different packages. Just trying to install the stuff and keep it updated for their staff. That's a funded effort in and of itself with IT folks. So having a unified product platform is really the direction that things have been headed. And my team and some of the other guys have been going through some of that change of, okay, how do we balance the need between people who need $500 software and people who need $9,000 software. And we're seeing a lot of mix of both, where people will buy some of the higher end products and more costly products for their niche applications, but for their more general applications, they'll use lower cost products. And it's been a pretty good business model. And now the idea is it's all marketed underneath the Fusion brand. In time, I think these things will all find their way into the Fusion canvas, but it'll take a little while. It's not going to happen overnight. It's going to take 3 years, 5 years. I mean, I'm sure development and management want it to happen in 3 months, kind of race to finish. But you know, 9 women cannot have a baby in 1 month, right?
Right.
So
Right. Yeah.
sometimes some things just take time,
Yeah.
and
Totally.
software development's definitely one of them.
Yeah. Well, when we've definitely seen, like you said, the integration. I mean, there's a little bit of Power Inspect in there now, and Steep and Shallow from Power Mill, and I've heard that the Part Maker team is now working on the turning infusion to kind of make it more acceptable and better.
Yeah, I mean that's actually been going on for quite some time. So Akash and some of the guys that were in my office, and when we started with this, HSM really didn't have a quality turning product, right? I mean, for them, like so many others, turning was an afterthought. Where I'm sure they had enough customers bug them that they need to have it. Somebody whipped something up, and we're like, "Here you go, this should work," right? But it wasn't really ever matured product. They had a nice milling product where their success was leveraged around their adaptive milling algorithm, right? It came out of Simco, and they had this high speed milling algorithm that was in the Mastercam product for a while. Autodesk um, acquired the HSM product and then ultimately integrated it into Fusion. But really, it was the 2D and the high speed stuff that made it good. And, when the turning bit started and we said, okay, hey, how can we start to take some of the Delcam technology from Part Maker and Feature Cam for turning and integrate it into Fusion? Honestly, I was involved with that process because they didn't really have folks with domain knowledge to determine that. Because I used to be a thorn in the side of development at Part Maker, right? I was sort of this honorary or dishonorable developer where I just went back room to shake folks down, right? Because I was on the front lines of hearing the complaints from customers and what we need to do. So I used to go in the back room and argue with Lena or Hanan or whoever in development about what we need to do the software and how we needed to do it all yesterday so I could sell more of it. Um, but I got quite involved in that process. And honestly, the first thing we said is we had to take all the stuff from HSM and scrap it and start over. And that's really what we did is we kind of went back down to their offsetting algorithm. So we started at like, okay, how do they take a curve and offset it to generate a turning tool path and then everything from there. And that's why you saw these new strategies come out because we basically scrapped the old strategies because they had integrated so many things that were sort of mismatched, like um, using a scan line approach, like you'd see in a G71 roughing cycle, right, where you take these horizontal passes with little return at the end of them, and then a G73 pattern repeating cycle where you just kind of keep offsetting the curve. And this was like blended into one thing in their turning tool pass and stuff that just didn't make sense, right? It was like if you were a chef or baker, right, and you watch somebody make a cake and they're like mixing the icing into the batter, and you're like, no, you have to bake the cake and then you put the icing on it. So at that point, we were like, just dump the batter out and let's make new batter. Which that's been a tough project because it's a big challenge for the developers to take someone else's code, right? Because you can only strip it back so far and then start over. So they've really started over from the ground up, and they've got a good bit on the turning algorithm. So like the part that calculates turning tool paths has come along. They still need to do grooving and threading, and then there's still some things about just generating the the defined profile, right? Spun profile and being able to create profiles just still doesn't have the intuitiveness that it needs to be robust and easy enough for my mom to use. So
Right. Yeah, that's the litmus test right there.
exactly.
So speaking of integrating stuff, I quickly before about an hour ago I put out a call to the audience just to see if anybody had any questions for you, and Emery Rempel had asked. Now that you guys acquired Camplete, and you had said that you sell a lot of simulation stuff, I don't know if Camplete is now going to fall under your jurisdiction as well, but are we going to start seeing that kind of integrated machine simulation jump into Fusion as well? Do you know?
Yeah, so I think the intent around that is really to do with Fusion more so than sort of putting that in the mix with, say, Power Mill or Feature Cam or Part Maker. Because one of the challenges, as you know, is getting a good post processor, right? So, um, Complete, their business model is kind of unique where you look at products like Vericut and NC Simul, where they just want to simulate the G code. And Complete takes an approach where they don't try to solve the problem of the customer per se. They do indirectly, but really where they try to solve the problem is with the machine tool distributor. Um, so what typically happens is somebody sells a machine tool to their customer. They already have some CAM package. They purchase a post from that CAM vendor, and depending on the quality of the product for that particular type of programming, whether it's turning or milling or turn milling or wire switch, what have you, 5-axis, 2-axis, so they get this product, they get a post which may be well proven and robust, and the applications team at that reseller or that cam vendor may be very knowledgeable about that machine, or they may be clueless and they about to go on an adventure. But either way, that somebody gets delivered a post, and even when you have a lot of knowledge about a machine, there's always something that's not right. And as much as I'd like to take the blame, one of the real challenges is a lot of machine tools aren't consistent, right? So you're trying to build post processors for hardware that whenever you work with a new variant of that hardware, doesn't behave exactly the same as the last variant. So it's kind of a moving target. But so what the Complete guys attempt to do is, you know, when people get that post processor and now they fight with trying to get things to work, right? Sometimes it goes smooth. We're like, hey, I need to do this or that. And, they have the right product for the right machine and they're able to get it working with not a lot of effort, right? Other times they just want to rip their hair out and they're screaming at the machine tool builder or the machine tool distributor. They're screaming at their CAM vendor and they're just like, this is horrible. I hate this. What is wrong? Is it the machine? Is it the software? And this is where Complete comes in, and they have strong relationships with a handful of builders, typically around the more complex 5-axis mills, because this is where people will spend the money on a good simulation product, right? It's hard to justify on a 3-axis mill to buy a product that can cost upwards of $20,000, right? To get a good post and simulation. But when you have a higher end 5-axis mill, it's you spent at least 150K, and if it's a better one, it could be as much as $750,000 to get this machine. And you're like, hey, yeah, I need to spend 20 grand to get this thing to go. Yeah, I blew that in a few HSK holders that I ordered that I'm not even going to use yet. Right. So,
Right.
and
Certainly cheaper than a spindle.
yeah, exactly. And so at least CAM you use on every job, whereas the holders you might not. But Complete has the relationship with these builders where they dial in their simulation and their post, and so that's what's a bit more unique about it is they develop a post that now takes generic output. So APT, CL data, whatever you want to call it, it takes a sort of raw toolpath data from pretty much any CAM system. They post process it and they simulate it, right? So they're only post processing and then simulating their own G code from their own post. So you can't take a post from, say, Fusion that is not just a CL data or APT post. Like you can't take your brother post and feed that into Complete. It won't accept G&M code. It only accepts that raw APT or CL data file, because now that they can control the post process procedure and the simulation, they're able to ensure robustness that the code will run and that they can pick up any and all collisions, because they can predict every little nuance of how that machine behaves. Like, hey, do the rapids dogleg or don't they dogleg? Or, does the machine work in TCP or is it all pivot point programming or whatever it might be? All the little nuances. And, you know, in order to scale post processing, I think being able to take that Complete product and get it into the Fusion canvas and integrate it will make it a safer product, right? So that people can run it with confidence, because you know half the battle of using a CAM product is having confidence that the product and the post processor are going to output code that aren't going to crash your machine or burn up your spindle or just make bad parts. Um, and I think that's where the key of this is at the end of the day, is leveraging that relationship and history with these builders and the posts that they have and getting them connected with Fusion. I mean, today you could take an APT post. There's a post with Fusion. You can dump it out and put it into Complete and run it. But Autodesk is going to have to move towards the subscription model with Complete yet, and then do some integration in Canvas so that you don't have to use two products. I mean, while having a separate product is fine, I think we all want that sort of one tool to rule them all. And I think when it's integrated and price adjusted for subscription and built in the Fusion, I think that's really where it's going to help Autodesk scale up. And that's a lot of big challenge with CAM in general, is trying to scale your business and have a lot of users, yet still provide them with quality post processing for more complex machines. That's what Complete's going to help Autodesk solve at the end of the day, in my opinion.
Yeah, that totally makes sense. So I written a couple questions that I just wanted to go over. The first ones were just kind of like, what makes Power Mill and Part Maker so special? And do you guys even sell Part Maker alone anymore, or do you have to buy it through a VAR, or how does that work?
Yeah. So I guess two answers there. The past year, actually, I guess this started last year. We went from a direct business model to an indirect business model. So historically, Delcam sold direct. We had some resellers, but the large majority of our business was handled directly. Since we've adapted to Autodesk business model, which is the large majority of their business is handled indirectly. So outside of Autodesk named accounts, which are typically larger organizations that have large annual spends with Autodesk, they don't do direct business, right? It's all done through their partner channel. And with the CAM products, we didn't just want anybody that was allowed to sell AutoCAD to be selling PowerMill because that would create a bad experience for our customers. So we created a certification process that people actually have to know what they're doing with Moldflow and know what they're doing with PowerMill and PartMaker in order to sell these things, support them, etc. And our team backs them up. So we have this business model where we're a direct led, indirect business model, right? So our team does sales, and we have some technical sort of pre-sales folks, and we help the resellers continue to grow their business. So very large amount of our business goes through these resellers. They've all been vetted in different specializations, whether it's material analysis like Moldflow or CAM for things like PowerMill and PartMaker and FeatureCam to be able to deliver the sort of quality of training and expertise people need to be able to implement, right? Because in order, for, again, for Autodesk to get scale, we can't do all this ourselves, right? It's all these little organizations that are, typically, smaller companies, right? I mean, while we have some very large VARs, some of our CAM VARs are often smaller companies where it's a family business and there's 20 employees, so it's not huge. And these guys can really bring the domain knowledge and expertise, and having multiples of them is where we start to get the scale by having them all over. Uh, and then when it comes to the product packaging, when we went from Delcam to Autodesk and sort of rebadged the uh, Delcam name and got rid of it and replaced it with Autodesk, we had to get rid of the amount of product variants that we had, right? It was too hard to sell at scale. When we had PartMaker before, there was like 20 different modules to it, and trying to get a team of resellers globally and even salespeople internally globally to sell these products and know which modules to sell which person, that's not an easy task, right? So by putting things in packaging that was really more of a good, better, best model, it made it so much simpler. Like, oh, you need to sell somebody something for this type of machine. Here, you sell them the good version. For these types of machines, the better version. And for these types of machines, plus the previous, this version. So during that repackaging, we found that a lot of people that wanted to program sort of general job shop, right? They're not doing mold, die, aerospace, sort of really high end 3D 5-axis work. They're doing typical job shop work where it's mostly 2.5D, some 3D, and some 5-axis. And then obviously their wire, turn mill, and Swiss type work. And FeatureCam and PartMaker have a lot of overlap, where PartMaker, it really excels in the multi-axis, multi-channel turn mill and Swiss area, whereas FeatureCam more in the automated milling area. So those products got bundled together where we had a few offerings where you could get only FeatureCam or PartMaker and FeatureCam. We've simplified that even further at this point, where we just made one version where you get fully loaded PartMaker and fully loaded FeatureCam. And really, quite honestly, the pricing, what it used to be under perpetual license, compared to what it is today as a subscription, it is a huge value for what you're paying. I mean, that software, if you had bought each of them, you would have spent over $50,000 for both of them, right? And then been paying maintenance costs on that. So being able to buy that today for about $5,000 subscription and having both those products, even if you don't use one of them, there's still pretty huge value. Um, so yeah, that's how we offer those today. And different resellers kind of specialize. We have some resellers that are a bit better with our Power Mill products and a bit better with Part Maker. But at the end of the day, it's all been converted to subscription. So it makes it easy to get in. You don't have to spend $15,000 or $25,000 to find out if the product's right for you. Um, the great thing actually about that whole change, which man, I can tell you that scared a lot of us, and I think it concerned a lot of other people too at Autodesk that weren't necessarily just selling the CAM products, right? They were just used to selling perpetual licenses. Is that whole transition to subscription is, hey, I really have to make sure that I sell the right thing to my customers. I also have to make sure they adopt it because it's easy to walk away, right? So if I sell you a product and you don't like it and it doesn't work for you and you don't implement it, you didn't spend that big upfront cost. And you go, I'm just going to walk away. Whereas when you invest that large amount up front, there's no shared risk, right? All the risks on the customer, like, oh well, you spent all the money now, so if you don't pay your maintenance, that's on you, right? And now they're like, okay, let me give it another go. Let me retrain my guy. Let me take another crack at it. We're a subscription. Now we have to make sure we outfit the right product for the right problem, and prove the return on investment on it, so that when somebody subscribes, that they keep subscribing year over year, because that's the only way that the subscription business model works, is if people return to subscribe year over year, or if they do want to minimize costs, they can subscribe for a 3-year period. We're like, hey, I just want to lock in a lower price, and I'm good with this now. Now it's more about cost control. um, so
Yeah, I guess I never really thought of that that aspect of it. I mean, being a consumer of it, I never really thought of like there is a much bigger risk for you guys where I might just bounce to another cam system, at a whim. So yeah, I definitely have heard a lot of that consumer fear of like, oh, now I don't own my software. But I don't. I think that a lot of people don't realize the power that gives them as well.
Yeah, I hear you on the I don't own my software, and I get that from folks, but the reality is you never owned your software, even when you bought a perpetual license. If Microsoft changes the operating system so much that until there's a software that doesn't need an operating system to run on, it's hard to run something forever, right? I mean, Microsoft changes something, the software developer has to change something, so that if you try and buy a perpetual license, you could sit on it for 5 years, maybe 10. But kind of after that 5-year mark, you start needing help. You need post processors, you need to get things updated, you got to update Windows, because who knows what they've changed, and now you're back paying maintenance again. So I think the fear of like, hey, I don't own my software is just kind of an older way of thinking. And I found that a lot of people, it's easier when I'm like, look, this is a shared risk, because if you're not happy with this thing, then you don't renew it. So now that you spend money with me, I have to ensure that it works, so that when I come back to you next year, you're going to do it again. And most of the people that buy perpetual licenses that use the product, they're paying every year anyway. So while we didn't call it a subscription, people call it maintenance. It's basically a subscription, because if you need to get updates and you want to get tech support and all that stuff, you're going to pay that yearly cost. So I understand the sort of hey, I'm leasing versus buying, but I think that ship has sort of sailed in software. Cam is sort of the last one hanging on to it, because a lot of the companies are smaller. But you look at a lot of the other software people have purchased at this point. I mean, Office 365, right? I mean, you used to buy Word, now you're subscribing to the whole Office suite, and Adobe, and CRM systems like Salesforce, HubSpot, things like that. I think the whole subscription business model really makes it easier, and it's even more so for larger companies, because the whole hey, I own my software probably applies more when you're buying one seat, right? And you're looking at it smaller. You know, some of the larger companies actually, they'll buy seats and they'll lose it, and you know how much money it costs them in lost serials and dongles when they buy stuff and it disappears. Well, when you get a subscription, you're like, hey, I'm using it. I have this much of it. I know where all of it is at. I know who it's assigned to. And if somebody leaves and somebody comes on board, I can reassign it, and managing it when you have a scaled operation makes it a whole lot easier when you've got that sort of business model. So, you know, I probably see more of that from some of the smaller shops, and I hear it, but I think what we'll see in the next maybe 5 years is some of these other guys are going to, find it a struggle to really hang on to that old business model, because the reality is all software companies really only make money if you continue to pay year over year, right? Pay that maintenance plan, pay the subscription. That upfront cost really, gives people a boost in revenue, but it's not what keeps them in business at the end of the day.
Right. No, I agree, and I just think that as a consumer, I think that's a point that's lost on a lot of us. I know I never thought of it that way. That, like, you know, yes, you guys have the, you're selling the software and we have to keep re-upping, but like you said, we have to keep re-upping for you to make money. And I guess I think that power dynamic is kind of lost, or at least not very well transmitted to a lot of people. So that's a really interesting way to put it, and I appreciate that.
Sure.
So in that same kind of vein, what do you think the biggest mistake people make in choosing software is?
Biggest mistake. Um, that's a
Or maybe
tough
things that they
one.
should ask for, or information that they should ask for up front, that kind of stuff. Anything that comes to mind.
I think people tend, in my experience, when there's a salesperson or application person involved, people tend to make good decisions because they typically are um, thoughtful in making sure they understand that a product solves their problem and suits their budget, and look at where things are used. So I can't say I see things that are a real challenge in the decision making process, other than maybe when somebody shows up and hires a new employee and he knows a product and he just says, okay, this is the thing to use, and they don't want to learn something else. That would probably be the mistake that I guess I've seen sometimes, right? Like somebody says, oh, hey, I know whatever product it might be, right? I know Fusion, I know Mastercam, I know EdgeCam, whatever it might be, and they want to take whatever is implemented in that company and toss it, and then next thing you know, productivity goes backwards, or bringing a new product on board and not going through a thorough process. But I don't really see that as much. It's sort of the um, you know sticking with what you know. You have to stay open minded when it comes to implementing. And if somebody's implemented something and it's really working, and you're going to replace it, you need to do your due diligence there. And I find most of the time people do. If anything, sometimes people drag their feet on the, if it's not broke, don't fix it philosophy. And with technology, I think you need to do some continuous improvement and reevaluate what you're doing, right? Hey, if it's been 10 years since you've looked at software, it's probably about time you relook at it. Um, but I can't say there's anything glaring where I'm like, oh, I see this all the time and it's a huge problem. No, people tend to do decent job in software selection and understanding what it is that they need.
That's good. Yeah. So jumping back real quick, you definitely, emphasized why part maker is what it is. Why people choose that, but why would somebody choose Power Mill over, Mastercam, or Gibbs Cam, or something like that? What does Power
Sure.
Mill do so well?
Yeah. So, you know, with that product, uh, I usually tell people, if you want to drive around the block in an airplane, it can be a little cumbersome. But if you want to go across the country, it's great, right? So, most of these products that you mentioned are like cars, right? They're great for driving around the block. Maybe you go on a long distance drive, but if you want to go across the country, it takes a long time, right? Whereas Power Mill's more like an airplane. So when you want to do more complex 3D, right? When you have a lot of 3D tool paths, when the amount of 3D tool paths has become the majority and not the minority of the set of operations in your programming, and your experience with CAM, and needing a level of control that is very finite becomes important on both 3 and 5 axis, but on 5 axis even more so because there's more challenges there. That's really where that product excels. So if anything, you know, the shortfall of is it, hey, the simple stuff sometimes it's a little bit more difficult to do because it's like using an airplane to drive around the block. You could do it if you're good and you're careful, but car can be a little bit easier there. But without a doubt, when it comes to the complex 3D and the 5 axis, it excels. And I think a lot of that has to do with the fact that most organizations develop their own 2D CAM, right? Maybe not the high speed machining component, but the typical profile pocket kind of thing that tends to be in-house sort of work, the graphical user interface, and that sort of thing. But when it comes to 3D and 5 axis, a lot of people go to a third party company. I think about 70% of the industry, they go to Module Works. Right. So Module Works doesn't actually make a CAM system. They make a toolpath kernel or API, and you can effectively pay royalties to them, license this product, and put it inside your product to be able to get 3D and 5 axis. And the reason that most people do this is because the cost of being able to develop 3D and 5 axis milling in man hours or man years is probably a better way to measure it, is expensive, and you won't easily see your money back, right? So most people are like, well, I want to have a product in the next 6 months to year, not the next 5 years, and I don't have an infinite budget to develop this and just hire a ton of people and let alone find the right people to develop that 3D and 5 axis machining algorithm or algorithms, and they go ahead and license it. So the Delcam product, Power Mill, was a bit unique in that this started out of Cambridge University. So they had some funding from university and government, and were able to grow this. I mean, it started back as far as I think the late '60s. And there was a product that worked on Unix called Duct that was a mix of PowerShape, which is primarily a surface modeler, but also later added some triangle mesh and solid modeling to it. But built their own surface kernel and toolpaths with this Unix system that was all text based, right? Type all the commands. Later in the 90s, they developed Power Mill and sort of moved everything to Windows. And because they develop their own engine, you're able to do things inside the user interface that if you use an API like ModuleWorks, it makes it a whole lot more difficult to do. Not that you can't do it, it's just more of a struggle, because what you're doing essentially when you use a third-party API is you take your geometry and your parameters, you pass it to the black box, and the black box passes you back your toolpath, right? And you don't really know what happens inside the black box. Well, when you develop the black box, how things get processed in there and how they get passed back, and being able to pass a portion of them after the fact and then pass just that portion back becomes a whole lot more possible. So, being able to calculate a toolpath in PowerMill and then subsequently update the leads and links and gouge check them all and modify the tool axis is something that you just don't see in these other products. There might be a couple other in the market where people do this, and quite frankly, they're all the ones that don't use that third party API, right? They home grow all of their algorithms, and I think that's really where this product is unique. Is it's all homegrown, and it's very mature. Because both PartMaker and PowerMill. I mean, PartMaker started really back in the 80s, but as a product itself for Swiss and Turnmill in the late 90s. So, it's over 20 years old. And then Power Mill, I mean, it depends on where you want to measure it from, but we'll give it an age of at least 30 years.
Yeah, yeah. I pulled up the Delcam Wikipedia real quick, and yeah, they started in 1965 with that research. So it's probably one of the longer running programs out there, at least in some form or another.
Yep. Yeah, it's one of the early 3D machining systems for sure.
That's pretty amazing. And so that's, I guess, probably why Autodesk was so happy to acquire Delcam. I mean, I know we're starting to see, toolpath trimming and all of that pulled into Fusion because of that, how unique it is,
Yeah,
and
I mean,
steep and
so they
shallow and things like that.
yeah, so now what's happening is both PowerMill and Fusion get a joint development benefit. So when we develop something inside of what is used to be the Delcam milling kernel and is now the Autodesk milling kernel, we can put it in both products, right? So um, we took the HSM toolpaths, which they developed their own, and the Power Mill toolpaths, and these things are being merged into a singular kernel, so that if we wanted to put adaptive clearing, which we did inside of Power Mill, we can. Or we want to put something like steep and shallow inside of Fusion, we can. If we make an improvement to one of these toolpaths in terms of the quality of it, the speed of calculation, the safety of it, whatever it might be, then both these products can gain the benefit. So, that's one of the way we optimize resources to be able to, still have both of these products where, one really serves sort of a higher end 3D 5-axis, more niche application, where Fusion tends to be more generalized in terms of its applications.
That makes sense. So DFM Toolworks had asked, will we see, more of the trim stuff come over from PowerMill, where you can use a specific sketch or something more definitive to trim toolpaths? Because I think that's possible in PowerMill, right?
Yeah, so in PowerMill, there's a few ways you can do the polygon boundary, which is what they've pretty much implemented in Fusion. Although, one of the things that has been a focus is, let's not take PowerMill and stick it in a different box, because that doesn't serve any purpose, right? Just sticking PowerMill inside of Fusion doesn't really move the needle. It needs to be something of greater value. So, like when they put the toolpath editing in there, they hooked it up to history, right? And that tends to be the greater value, is let's associate this. Let's make things sort of auto magically update, um, or at least give you the control to rewind and fast forward them to some point in time. So I do believe there's something on the burner for doing boundary based, and that is technology from Power Mills. You can take a boundary and subsequently apply a boundary to contain a toolpath. Um, where it is in the scope of things, I'm not really sure. I know that they've got this tilt and turn. I think that's sort of the next big thing that is about to be released, or I can't. To be honest, I can't even keep up with all the things they put in Fusion. They put it in there so fast. Maybe it was already released, but that sort of ability to tilt the tool in sort of a widget, right? This the widget that you can tilt and turn and do things more intuitively than having to make all this, what I would call support geometry in order to assign a tool axis angle. I know that's one of their big things, but I think there's some more tool path editing to come, and clearly there's more technology from PowerMill to come. Probably the biggest thing is, Fusion's limited in what's in 5-axis, and there's a lot in 3D and 5-axis that's in PowerMill that we haven't yet seen in Fusion, that's yet to come. I think some of the things that they're doing is, when they're bringing these in, they're actually readdressing them in both products, right? So they're like, hey, if we're going to bring in corner finishing, let's go and address all the things in corner finishing that we really didn't address in Power Mill in the past 30 some years, right? Like, we got it this far, and yeah, it's better than anything else that we've got, but we really wish we could do this to it. So if we're going to integrate all this, let's spruce it all up, make it do the things we really want it to do, and then integrate it into both. So I know as they do these things, they're cleaning up. Even steep and shallow, they did some cleanup around boundary fragmentation. So like when you have a boundary around some area for steep and shallow, sometimes you could get little toolpath segmenting where you'd get link moves between them, and they did a better job of making sure that you don't get sort of these broken up moves, and you know just sort of polishing the robustness of it at the end of the day.
That's great. That's great for users of both products.
Yep.
That's really cool. So the way I was introduced to you is, Jake was talking about you helping him at his day job with posts and things like that, and it sounds like you've maybe not as your primary function, but you've definitely done a lot of post development. So I kind of wanted to ask you some questions about that and see what you think like the
Sure.
most important things to remember are when you're getting a post tailored, and just things that us or me as business owners and some of my listeners should be asking to the people tailoring our posts or helping us modify our posts.
Keep your hand on the e-stop button. It's very easy to break things, right? And one of the things about changing any code, it doesn't matter whether it's the source code for a post processor or a piece of software, is trying to make the least amount of change to achieve your goal, right? It's very easy to go in there and just tear something apart, or everybody wants to rewrite everything. Oh, this is junk. I'm going to rewrite it all, and what I'm going to do is be amazing. And you're just going to make the same garble that somebody else made, but in just some way that you understand it. So I think when it comes to editing post, there's this universal truth with any code editing, which it's much easier to write code than it is to read code, which is why everybody likes to rewrite stuff. So I would make sure that you read and really understand what's going on with things. And, look at the documentation. The documentation on the JavaScript based posts for Fusion is actually pretty decent. Um, Granted, the problem, as I mentioned earlier, is having the time to A, learn JavaScript, and B, understand the flow of everything inside of there. But going in there and making the least amount of change to achieve your goal without sort of going in and cutting all the wires and trying to install all new ones. And then when you do it, you know do some basic testing. I mean, it's not hard to output a series of processes to test the typical permutations, right? So it's like, okay, let's just say it's a 3-axis machine. Well, going from tool change to a non-tool change process, right? So using the same tool back to back, going tool change to tool change, testing the very first process and the very last process. Things where okay, what could I run into problems? Oh, here a 5-axis machining. Well, let's test multiple angles and going from 5-axis to 5-simul and 5-simul. When I say 5-axis, I meant 3+2. Going from 3+2 to 5-simul and 5-simul to 3+2, or 3+2 to 3+2, and making sure you're seeing the right header and footer cancellations between different commands that may be modal or non-modal, or having rules about ordering things like that. But you know, taking your time, that's the biggest thing, and be systematic. Whenever I've helped customers implement post processors, you got to break it down into the small bits. Like if you can't just swallow the world when you try and do this stuff. Especially companies that have a lot of machines, right? I mean, it's easy when it's just a post for a machine. Well, what if you have a shop and you've got 50 different machines, or even 10 different machines? You got to pick a machine and go a mile deep with that machine, or at least a half mile deep. Whereas if you try and do all 10 machines at once, you're just never going to get anywhere. After about 10 years of helping people implementing post processors, those would be my bits of advice.
Okay. And then for people that, are going to you or a VAR or something like that, what would you say is like the list of things that they should bring with them to make your job the easiest? Like, should they bring parts that are already programmed and that they want to see these changes made to? I mean, obviously, code before and after the changes is helpful. Like, what's the list of minimum requirements that would really make your job the best?
So, regardless of the system, having a native file programmed in there, preferably not one with, 500,000 lines of output code. Right. So ideally a part, while it's welcome to be complex, but you don't need to make tool paths that have the tightest step over. Like you can go in there and loosen up a step over or something, or a step down, or a number of passes or whatever, just to make the code a little bit more succinct for output. um, and so having the files that will produce that code, having the post that produces that code, and then having an edited version of the actual output. So this way, what I could do as a post author is I could have those files and I could reproduce the output that is, quote, wrong. I could do a file compare to compare it to the file that is right. And now I just modify the post until it produces the file that's correct. Right. And then usually it depends on the competency of the person doing the post writing, which that can be a challenge. Is you have to understand the machine, understand the G&M codes for that machine, and also understand the software and the post processor. Is understanding something about the changes, right? So I may just see that you move something around and I'm like, well, why'd you do that? Well, here, the intent here is that this has to be after this code everywhere where this code occurs, or some sort of notes to go along with it. I mean, I helped you with your brother post, and there was something, I forget what it was, but I did it, and I'm like, oh yeah, he's gonna love this, and you're like, no, 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 it has to be here on all of those. I'm like, oh, you didn't say that, right? Because
Yeah,
I didn't have a sample, and I didn't have some notes, right? Or I guess all I had was the notes. So that's the ideal scenario: is files, post, corrected G code, and some notes about the corrections in the G code. And then now it's just a matter of playing the game of change the least amount of things in the post to make the output look like the, quote, corrected code.
yeah, I think that totally makes sense. And that was definitely my bad.
Speaking of which, how does it work? So did we make your life better or worse, or you haven't used it, or what happened with your brother post?
I have not used it. I after you helped me out to getting those high speed codes in there, I went to go install their all the parameters in the machine for the high speed codes, and then ended up having more questions because the guide I had to the high speed codes was from a few firmware versions ago, and so there were boxes that I had no answers for, and so I ended up going on a 3 or 4 day quest, figuring out what's supposed to be in there, what does it matter if I have nothing in there, and only recently did I get it sorted, and now I'm running production on our holiday ornaments, and so I haven't had a chance to post any code with it yet.
Gotcha. Okay, you have to let me know how that goes.
Oh, I definitely will. And then the last question I had written for you was, "What's your most interesting customer request?" It could be on the software side or the post side, or whatever you can share that you think is a good story.
Um, hmm. I mean, we everybody gives their request about what whiz bang automated thing they want the software to do. Ideally it's I want to hold the print up to the monitor and have the machine make the part. But outside of that sort of you know auto magic programming, it's typically some interesting things that I see with how people write code. Um, you know, Automation things. Uh, I actually saw one thing that Jake did. I don't even think he did. Somebody else did, where they put matrix code, right? Like rather than barcode, they put matrix code on parts. Um, and I've seen other people do other little um, snippets of subprogram calls or insertions of other things where they've got something that really helps them in the processing of that job, like inserting tool life macros, or anything that typically it revolves around leverage of macro B and the conditional statements inside there. I mean, I just helped somebody the other day on LinkedIn that works for a customer where he wanted to macro B out some threads. And I had actually done that in a part maker post where we use a while loop, a while do statement to iterate each step down in X rather than having to have, all these points over and over again because it makes the code a little bit more legible and succinct. So I'd probably say, some of those sort of macro B logic based um, G code output and that coming from a software because that's something that CAM software generally doesn't do well with, but you can bend it to your will and get it to do some pretty cool stuff. Um, so
Yeah, yeah, I agree. I only just kind of breaking into the world of macro B, and the more I learn about it, the more fun it becomes. So I
yeah, there's
definitely
lot of
understand that.
process control, right? You can handle duplicate tools after so many parts. You can have it switched to a sister tool and track all of that, or have it automate something where you could easily size a part without having to re-output the code and all this kind of stuff that just makes your life easier on the shop floor at the end of the day.
Yeah, yeah, I think that to any of my listeners who don't use macro B, I mean, even easy stuff is really really nice to do with it. Like I'm currently working with our Simco guys at my day job to insert statements at each tool change to make sure that there's a height offset for each tool so they don't crash, the spindle into a part with a zero height offset or something like that. And just little things like that. There's so many ways to add checks and balances into the programs that otherwise these dumb machines don't have. So
Yeah,
it's
for
it's,
for, for
it's
sure.
awesome.
It's sort of how many ways can you stop people from breaking things, right? I mean especially in a production environment, right, where you may be having people run machines that are not machinists, right? They're operators and in their truest sense. Like, hey, this guy was working at a retail store and now he's going to run the machine, and you put the part in here, you do this, and it's like, okay, here, let's give him a torque wrench so he makes sure to tighten it properly because he doesn't know how hard to wrench on that thing. Do I crank it all the way down or soft or hard? It's like, no, you turn the torque wrench until the little needle goes here, and then you're good, right? And and the G code here, when you hit this and this hits here, it'll ask you a question, and you can do this at the machine, or it'll prompt you for that, or all that kind of stuff. I saw, um, you know, I was helping Jake with something that the Haas machine puts images in their control, which was kind of nice, right? To basically now understand, what's going on, having some sort of image, or I don't know if it supports video or not. It even makes sense to have some sort of video in there. So it's like, okay, how do I run this thing when the guy to ask isn't standing next to me, without standing at his office until he gets off the phone so I can, get an answer to a question. All that kind of stuff is super helpful in a production environment.
Yeah, yeah, and I know the host control allows those questions as well, like yes, no kind of um, questions within the control, which is pretty neat. So, one other question that kind of came to me while you were talking about your backstory is, I think a lot of us come up in shops where people are doing things the old way, and you were talking about, having to hand file all these wax forms for rings and things like that.
Mhm.
How long did it take for your dad to get on board with CNC and then CAD and all of that? Like, was there a lot of pushback, or was he pretty quick to trust you and adopt that? Like, how did that whole transition go?
Yeah, so I mean, honestly, we went to a trade show. I saw it. He thought it was as cool as I thought it was, and we just bought it pretty much on the spot. I mean, we had looked at a couple of them. We had looked at what was effectively Rhino, or this sort of overlay for it called Matrix, and Delcam's Art Cam, and we actually had purchased the Rhino based product. Um, you know, by the time we were done the show, and we're we're home and sending off CAD files to have Service Bureau 3D print models, and then trying to figure out, okay, what do we charge and how do we integrate this into our business, and you know, what's the time that it takes to model something? How do we estimate it, right? And sort of understanding all the non-technical things about, how do we make money with this thing. Um, but he was all game for that. And then when it came to the machines, that was just a matter of like, okay, well, look at after the first year of outsourcing, having little waxes CNC cut or 3D printed, and or making silicone molds of SLA parts. What was our service bureau bill like? And if we consider the cost of the machine, the cost of the headache of having to do the work yourself, what the opportunity cost of other things that you could be doing, what should we bring in house? And we ended up bringing the CNCs in house, um, because of the cost of them and the reliability of them. Whereas the 3D printers are a little tougher because there's a few different technologies, and to really have them all and to have some of the better ones get quite costly to bring in house. Although today it's a bit different because a lot of the patents have dropped away from 3D systems, and there's a lot of DLP technology that can get some really high resolution small parts for very little money. But back when I was doing it, that was not the case. If you wanted to do stereolithography or DLP based printing, it was a hefty price tag. But we got in the CNC, and then I was doing the work with Minitech, so we were working in trade for equipment. So I was sort of moonlighting as an application engineer for them, traveling around and, learning all this stuff. And, at that point, it really wasn't up to him anymore, where I was getting the equipment myself. Um, but we invested in other technologies. A laser welder we had for being able to work under a microscope and do laser welding, and other software where it was just like, hey, you can go buy a CRM POS system, and go spend 10 grand on it or 20 grand or whatever it is. Or I can write one because this is what I want to do between, 10 o'clock at night and 2 o'clock in the morning. And then some days at work. And he's like, yeah, go for it. But I needed to do this, and this for us to get rid of our old one. And my dad was a pretty big technology adopter. I mean, he started me on computers when I was really young. He developed our previous POS system in a software called Paradox, which was a flat file database. And he wasn't a software developer, right? I mean, he and his friend learned it the hard way, just working after hours, just trying to make things work, figuring out. And he didn't have the internet to go search. I mean, thank God today you can go Google your way through most of your challenges. I mean, you still got to figure some things out, but people always joke with internet memes that coding is mostly copying and pasting things off of Stack Exchange. And just finding the right things to copy and paste. So there's some level of truth to that if your problems are simple. But no, he was always good with adopting technology, and he realized that you know putting technology into business has its advantages for sure.
That's awesome. That is, I feel like not the usual response that a lot of us get in manufacturing, at least, and maybe that's because it was manufacturing adjacent. But I know, like you were talking about, or we were talking about software and perpetual licenses and things like that. Like my first boss, all of the computers were Windows XP until the end of life of Windows XP because he didn't, trust the next generation and didn't want to lose all of our perpetual license software and all of that stuff. So
Well, yeah. So that, I guess that's different. There's a difference between being a luddite and not wanting to update what you have, right? So, I think like anybody, in a small business, there was definitely things that we would not do. It's like, oh, well, do we need to update this? Well, not unless there's a very compelling financial reason to do so. Let's not do it. We don't just have cash to burn, right? So, not racing to go update Windows until Microsoft wants to update you for free isn't a bad strategy. Um, but when it came to just bringing in new technology, like you know, if you didn't have CAM or your CAM was ancient, you're like, hey, we need to improve our programming and setup times because that's a bottleneck. And by doing so, we will make money. So spending whatever amount of money you need to do that, if it's cost justified against the savings you'll receive, you know, how do you not do that, right? I mean, you're going to save people unless they're just buying on emotion. People typically don't buy things unless spending money is actually going to save them money or make them money, right? So in that sense, I definitely think I had to cost justify things, and it wasn't just like a hey, here, go buy whatever you want, how you want, when you want. It was like go buy things that will help the business grow and or make more money at the end of the day. Um, so
Yeah, yeah. I mean, that totally makes sense. So the last question, and this is one that I ask every single guest, is what did you research this week? It can be manufacturing related, it can be not manufacturing. It's just always really interesting. I mean, I think most of us that do some sort of technology thing or manufacturing are always Googling something. And so it's always interesting to see the wide range of responses I get.
so I will say that in order to get some sort of, I guess, intellectual satisfaction that maybe I don't always get from being in sales. I spend what spare time I have when I'm not with my family, my kids, um, doing something related to software development. I was actually working with some lower cost CAD API to be able to integrate some 3D, and being able to create some tool paths to do like a little bit of CAD CAM development, and not having to go buy the real toys like Parasolids and Module Works, or spend the next 10 years doing something, but it's sort of dabbling enough to making little applications, and just seeing if I could do it, and what I could achieve with it. So um, I would say I spent plenty of hours researching CAD CAM, and sort of the development of it, and trying to do things that probably most people would do with C++ or C, and doing them with a little bit higher level languages like C sharp .NET or JavaScript, or things that don't have the sort of same amount of man hours required to get something to draw on screen, right? I don't want to be doing super low level development that takes a year just so I can get something simple to happen. Just more for kicks at the end of the day.
That's cool. That's a great way to keep your, programming chops out too.
Yeah, yeah, just trying to learn a little bit more than working with existing products and dabbling with posts, right? I mean, after that, it's like, okay, hey, can I make some of this myself? How hard is it to do? How hard is it to do graphics drawing with Windows? And what are the tools that are out there? And you know, things of that nature.
That's really cool. Yeah, my first boss and I, we talk, I don't know, once or twice a month, and he's been, since I know him, maybe 10 years now or 8 years now, he's been building his own CAM system within AutoCAD, and programming it all in Lisp, and it all, it's got setup pages and draws on screen and all that. So it's always cool seeing those kind of homegrown and homebred solutions.
It's funny you say that because, when Autodesk first acquired us, and, there was talks of, oh, yeah, Fusion and integration with Fusion. And I'm just like, how come nobody wants to make AutoCAD CAM? Would that be the thing that everybody would buy? Because everybody has AutoCAD. Wouldn't they just want AutoCAM? So apparently your boss does, or your old boss does.
Yeah, yeah, he's a big fan, and it's not even current AutoCAD. I think past a certain version, it all breaks down, and he's been looking into. I guess he's good friends with the guy who runs BricsCAD, and
Okay.
so he's also been creating his module for BricsCAD as well, because that's well, more modern version of his ancient AutoCAD version. that he can implement all this in. And
Yeah,
so it's interesting.
that's always the challenge with you know add-ons is trying to keep them working in the newest version. I was just talking with another customer who was struggling using a third-party cam system, or sorry, a cam system with a third-party high-speed machining plugin. And we used to have a saying in our office that nothing good comes out of the plugins menu. And the idea behind that is typically things in the plugins menu are sort of home baked or partially baked, and if they were fully baked, they would have just been in the software. Um, that's always the challenge is kind of bolting on to other things. But hey, if he has fun with it and it does what he needs, cool.
Yeah, yeah. I think it's at this point just a pet project that keeps his brain active and keeps him, like you working on programming and all of those kind of skills. So I, I think he thinks there's a small market out there, like you said, of people who have AutoCAD and would love something that just plugs in and can work. But I think he knows that at this point, there's a lot of options out there, and it's just more of a pet project for him.
Yeah, if anything, that might be an aging community, right? I mean, I don't see a lot of people jumping to 2D these days. It seems like everybody wants to go straight to 3D and you know draw bad parts in 3D and try to manufacture them. And then you're like, why would you draw this like this? Have you ever made something before?
No, it's so easy to hit the fill it all button. Of course, I'm going to fill it everything.
Uh,
Yeah. Well, again, thank you so much for coming on the podcast. I really appreciate it. And yeah, just thank you so much.
yeah, yeah, appreciate it. Thanks for your time. This is great, and let me know how things go once you get your high speed codes there all tuned up on the brother.
I definitely will. I appreciate the help. All right, guys. Well, thank you so much for listening, and we will be back next week.